All right, let's do this. Let's predict the test set results. So, as I said in the previous tutorial, we're going to display two vectors. First one being the vector of the real profits in the test set, and the second one being the vector of the predicted profits in the same test set. And we're going to compare next to each other to see if our predictions are close to the real results. All right, let's do this. Let's start by creating a new code cell. So the first thing I asked you to do was to indeed get that vector of predictions. So first, since we want to get a vector, I'm going to introduce a new variable, which I'm going to call, as usual, ypred. So that's going to be the vector of the predicted profits in the test set. And now, how do we get our predictions? Well, you know the solution. It's actually exactly the same as with simple linear regression. We first need to take our regressor object, our multiple linear regression model, from which, adding a dot here, we're going to call that predict method, parenthesis. And of course, in this method, we have to input, the features of the test set, exactly these ones, not including the profit, of course. These are all the features with first the encoded variables for the state, then the R&D spend, then the administration spend, and the marketing spend. All right, so these are all the features which we need to input in our predict method here in order to predict the profits. So let's do this. X test, right? Because we're predicting the test set results. We want to check the predictions of new observations. And there you go. Now we get our vector of predicted profits. Perfect. And now the next step, and here we're going to do it together because it is quite specific, and mostly I want to display some nice vectors with not a too complex notation, like, remember this one in the data preprocessing tools when we applied feature scaling, we had all these decimals after the comma. Well, I want to avoid this, and therefore here, the thing that I'm going to do is I'm going to call numpy, which has a shortcut np, from which I'm going to call one of its functions, which is set underscore print options, as Google Colab guesses it perfectly. That's great, it helps me. And now in the parenthesis, I'm just going to enter precision equals 2. All right, and this will display any numerical value with only 2 decimals after comma. All right, so this will be much more beautiful to visualize and mostly much easier to visualize. Okay, good. And now final step. This is a step where we're going to display the two vectors of the real profits and of the predicted profits together, next to each other. And to do this, we're going to use, a classic trick with NumPy. I remember that NumPy has a lot of tools to handle arrays, and one of these tools actually that we need right now is concatenate. Concatenate is a function of NumPy that allows to concatenate either vertically or horizontally two vectors or even arrays. And so now we're going to use the concatenate function to concatenate vertically our two vectors of the real profits and the predicted profits. All right, so let's do this. Just follow me. I will explain everything as I'm coding. So first, we're simply going to start with a print, because we want to print that concatenation of the two vectors. So print. Then, here we go. We're going to call that concatenate function by numpy. So that's why I'm calling its shortcut np now, from which, yes, there we go, we call the concatenate function. Perfect, parenthesis. And now be careful, because this is always a bit confusing. The concatenate function by numpy actually expects as a first argument, check this out here, the tuple of arrays you want to concatenate, or, vectors. So actually all the description is here. A1, A2 is a sequence of arrays you want to concatenate, and that must have the same shape. Well, that's perfect for us because, of course, our vector of predicted profits and the vector of real profits have exactly the same shape, meaning they are a one-dimensional vector containing the same number of profits. Okay, so that's good. But these vectors that we want to concatenate have to be in some parentheses, and these are actually the first argument. This tuple of arrays or vectors is the first argument input in parentheses. So here I'm going to add new parentheses. All right, this is the first argument. And what is going to be inside these parentheses? Well, of course, are two vectors, the vector of predicted profits and the vector of real profits. All right, so let's first add the vector of predicted profits. This is, of course, ypred. And now, because we want to display them vertically and not horizontally, remember that, actually I can show this to you in data preprocessing tools. We actually printed y at some point. There we go. Remember when we print the dependent variable vector, since it is vector, it is displayed horizontally. I actually prefer to display, our two vectors of predictions and real profit vertically. So now I'm going to add another trick to put that vertically, to convert that from being horizontal to vertical. And the trick to do that is just to add dot reshape. Reshape is an attribute function that allows to, reshape your vectors or arrays. And in order to reshape a vector from being horizontal to vertical, well, we just need to add as input of this function, first, the number of elements in ypred, and that's actually so far the number of columns because, it is horizontal. And to get that number, we can simply use the len function, which returns the length of a vector. And therefore here, I'm going to input ypred. Okay, so this is the first element of the reshape function, and the second one is just 1. All right. So what does it mean? That means that you want to reshape your ypred vector into an array having len ypred rows, meaning that the number of rows will be equal to the number of startups, and then just 1 column. All right, that's what it means. So it's good that you know this reshape trick. Now you know how to reshape your vectors, and you will see that it is actually going to be much nicer. All right, so that's for, remember, the first element of this tuple, that is actually the first argument of the concatenate function. And now, next one is going to be, well, the other vector we want to concatenate to that vector of predicted profits, which is the vector of real profits. All right, so here we can do this very efficiently because this is exactly the same trick. I'm going to copy all this and paste that here and just replace ypred by, what do we have to replace ypred by? Well, of course, we have to replace it by ytest, because ytest contains, of course, the real profit in the test set. All right, here we are evaluating our model on the test set. So here we go, replacing ypred by ytest, and here as well, actually we could keep that because the length of ytest is the same as the length of ypred. But there we go. Now we have a beautiful concatenation of two vertical vectors. But remember this, this up to here is actually the first argument of the concatenate function, and therefore we need to add the second one, which is the axis, as you can see. So axis here can take two values, 0 or 1. 0 means that we want to do a vertical concatenation, and 1 means that we want to do a horizontal concatenation. And since here we want to concatenate two vertical vectors together, well, that concatenation is actually horizontal, and therefore we have to input here axis equals 1. And we don't have to specify the name of the argument because this is input in the same order. All right, and that's it. I told you that it was better that we do it together because there are actually a lot of tricks done here, but don't worry, for all the next times when we want to compare two numerical vectors, we will just do some copy-paste and apply this. The purpose of this course is also for you to have some code templates which you can use efficiently on your datasets. All right? Okay, good. So now we're going to observe the final result and see if our model was able to return some predictions, some predicted profits close to the real profits. So there we go. I hope I didn't make any mistakes with all these parentheses. Let's press play to run the cell, and awesome! I didn't make any mistake. Perfect. So let's recap. We can clearly see that we have two vectors here. That's the first one, and that's the second one. On the left, we have the vector of predicted profit, so that's ypred, and on the right, we have the vector of real profits for, of course, the 10 startups of the test set. All right, and so let's see what we get. Let's see if our predicted profits are close to the real profit. So for the first startup of the test set, well, the predicted profit is around 103,000 and the real profit is actually 103,200. So very close. That's perfect. That's an amazing first prediction. Then second startup of the test set, the predicted profit is 132,582 and the real profit is actually 144,000. So not a great prediction like before, but still not too bad. Third startup, 132, 146. Still not great, but not too bad either. Fourth startup, 71, actually 72 and 78. All right, so pretty close. Then 178, 191, okay. 116, 105. So actually the first prediction was amazing, but then, the other ones are still quite good. Then 67, 68, actually 81, okay. 98,000 and 97,000, very good. 113,000, actually 114,000, 110,000, very, very good. And 167,000 and 166,000, amazing predictions. So we have some, amazing predictions, very close to the real profits, and some okay predictions, okay-ish, that are not too far from the real results. So here, from what we see, we could say that the multiple linear regression is well adapted to this dataset. The dataset does not necessarily have some perfect linear correlations. However, you can be assured that with this linear regression class, it was able to select the right features with the right parameters to make these predictions. And even if you tune your linear regression model by, for example, applying backward elimination to select, a team of more statistically significant features, you will actually get similar results. You can try that, actually would be a good practice. We actually do that in the R section, but in terms of performance, this won't change much. And remember, your goal is to be efficient when building and testing your machine learning models. So when you get such results with your multiple linear regression, in real life, you will actually try other models. You will actually try other modules which can tune also, and then in the end you will compare the performance of each of these models and select the best one. So we'll talk about this again at the end of this section, and also a lot in part 10 on model selection. And so now I have to say congratulations, because you now know how to build another machine learning model, which is multiple linear regression, and therefore which you can add in your toolkit thanks to this new code template. Perfect. So now we're going to move on to R. I remind that you don't have to master the 2 programming languages. If you want to master the 2, that's fine. Join me in the R tutorials. And otherwise, if you want to stick to Python, feel free to skip the R section and join us, Kirill and I, in the next section on polynomial regression, where you will learn how to make predictions on a non-linear dataset, on a dataset with non-linear relationships, therefore with which a multiple linear regression model would not be relevant. So it's an absolutely necessary model to add in your toolkit, and you will add it in the next section. Until then, enjoy machine learning.